Hi everyone, welcome back to Java 1 for All. In this video, we are going to talk about one of the methods that will always be there if you have equals implemented in your own code. The method we are talking about is the hash code. But before we proceed, it's a good idea to just have a quick and dirty understanding of how the hash works. And of course, you can go even deeper reading about data structures. But for now, just a quick explanation about what is hash and how it works should be more than enough for our training. So imagine that we have, this is not an array. Imagine that these are like kind of boxes. Because in Java, as I said, we have several types of collections. We have collections that, for example, can only have unique elements, collections where you have key value pairs, collections where, for example, you keep the order of insertion. And one of the type of collections that we also have available is collections that they are high performance collections. And these collections, they are usually hash collections, hash table, hash map, or hash set, so on. If you see hash in the name of the collection, probably they are using they are using this concept of hashes. So imagine, for example, that we have an array. Imagine that we have like maybe 1 billion names in that array. And you want to search, for example, for a name that's William. If you are doing the regular way, technically you would have to go over each one of the positions that we have in that array to find the name that we are looking for. So the bigger your array is, the lower your performance to get the results back. But when we are talking about hash, it's kind of, imagine that you have the same array, 1 billion positions, and you would like to return position number 1,055. The performance is always the same because you are going straight to that index. And this is kind of similar a little bit how the hash is going to work. For example, hash is something that we have to generate. There are theses explaining how to generate a good hash. But for now, let's imagine that we have the following. Imagine that each one of the letters will represent a number. So for example, A1, B2, and for example, C is going to represent 3, and so on for all the letters in the alphabet. If we have a name, and let's say that we have here Alex, if we replace the letters with numbers, we would have 1, 12, 5, 24. So this is equal to 42. If we have another name, for example, Bob, we would have 2 plus 15 plus 2. This is equal 19. So we can say, for example, using our very, very poor algorithm, that the hash for Alex is 42 and the hash for Bob is 19. So if we have a collection, we have here a collection of names, we have Alex and we have Bob, and we kind of have a hash identifying them. So for example, we have a hash here that represents Alex. This is not index, this is hash 42, and this one is 19. For example, now imagine that I have like the same number that we were using before, 1 billion, but instead of indexes, we have now hashes. And I'm looking for Alex. And once we generate the hash, basically we go straight to the like identifier index 42, and it's going to return the Alex for me. So basically, in a very, very short way, this is a little bit how the hashes they work. But we have a problem that's called hash collision. Imagine we have the following. Let's say a name called Dirk. Dirk, if we replace, we have 4, and we have 9, we have 18, and we have 11. And this is also 42. So now for the hash 42, we have also Alex, and we have Dirk. And this is why I said that most of the times when you are overriding the equals, you are also overriding the hash code and vice versa. Because once Java finds that hash, basically 42, it's going to get the value. But then what's the value that you are looking for? Well, the value we are looking for in this case would be Alex. And that's how the equals is going to be triggered. because for Java, once it finds the hash, it needs to find the perfect value that we have inside our box. And then only equals will be able to tell if the object that you're looking for, it's there. So that's why it's important to generate hashes that basically will have one relationship, one hash for your value. And that may be a little bit difficult to do it, but is probably not impossible for us to create a very good hash that will keep the performance of our systems very good. So this is just a very, very brief introduction about how hashes work. And in the next video, we're going to see how to provide the hash implementation in our Java object. So I hope you enjoyed. See you in the next video. Bye.